it's, I don't know, 357 meetings. So just go for it.
So welcome everybody on our AWS meetup. Today we'll having two great topics. Maybe you want to talk about it.
Stage is yours, man. You know, so generally speaking, we'll have two topics, but deliver completely different ways. So one way is it's going to be a hybrid meeting. So you are here, but our lovely speaker is outside somewhere there in Poland. Unfortunately, she couldn't arrive here, but you will join us on the stage, right? Yeah. You will just, and you will be like an introduction. Okay, perfect. And the second one? The second one, yeah.
Second will be here on the stage, so we'll be able to meet and greet him.
Remember, here is the line, the camera. If you don't want to be online, you just go there, and you're not online anymore. So it's a hard stop, you know. So here you're online.
Always hide behind the desk.
Okay, so I don't know which one is it? 50, 60, 70, 70, I think. 70-something meetings. So we are quite time here in Krakow from the stage of meetups. But remember, this stage is for you as well. So if you want to have any subject to talk about, don't hesitate, ping me over Meetup, Maria, and we can arrange that, right?
Sure, for the next one.
For the next one. Okay? Come on in. Come on in.
It's on me.
It's on you.
Let's give a round of applause. Hi, I'm Kuba from Ocado engineering team. I'm here before I bring up the first speaker. I want to give you a brief overview about Ocado. So what we do, we build fully automated warehouses. As you can see, those little bots on the screen, we build them, we maintain, and operate them. When you order something online from one of our customers, those bots will pick up your order and then prepare it for the delivery. Basically, our goal is to make sure that your order will be delivered to you fresh and fast. We are using technology from multiple various areas, like obviously cloud, ML, AI, big data, and robotics, of course, to deliver advanced e-commerce fulfillment and logistics solutions, which we call Ocado Smart Platform, or speak in short. Small local flavor, since we're in Poland, we've got a customer in Poland, it's Auchan. They are already running their online store on OSP, and their first fully automated warehouse is currently finishing the build in the Warsaw outskirts. So if you are living in an area, you will be able to try it yourself from the store customer perspective how the delivery will go. But without any further delays, let me introduce Julia from the same team as me with her presentation about automating data flows with cross-cloud data pipelines. Over to you, Julia.
Thank you, Kuba. Okay, but one question, can you hear me? Because I can't hear you. Hello? Oh, okay. Great, thank you, Ola. So hi everyone. Sorry I can't be there with you in person today, and thanks a lot for joining to our session. I want to give you a quick look at how we build an automated data pipeline that pulls data from different SaaS platforms, processes it in AWS, securely push it to Google BigQuery, and make it ready for dashboards and reporting. A quick introduction about myself. I'm an InfoSec engineer at Ocado. I live in the clouds, also as a second-year AWS community builder and a two-time AWS All Builder Welcome grantee. In recent weeks, I've been focusing on building and improving cloud pipelines. And this project is a good example of how we can make our daily InfoSec work simpler by automating something that used to be done by hand. And here's our agenda. We will start with the challenge of manual security data extraction, then walk through the pipeline architecture and how we move data between AWS and Google Cloud. I will show the impact for stakeholders, our stakeholders, and how this setup scales for future integrations. We will also touch on maintenance, next steps, and key lessons learned, and finish with a short Q&A. And yeah, I'd like to begin by telling you a short story. Before we built this pipeline, our security teams had to log into different SaaS platforms every month. They exported user data, security test results, and threat intelligence manually. Then they cleaned the files, combined them, and finally uploaded everything to build security dashboards in Google GCP Looker. These dashboards aren't just nice to have, to be honest. They're the main way we communicate security insights to our stakeholders. For example, we use them to show key metrics like the percentage of logins from specific regions, results of awareness tests, or the number of detected threats over time. Preparing this data every month took hours. And because the process was manual, mistakes happened, of course. Teams were spending valuable time on manual work instead of focusing on higher impact security initiatives. Reports were often delayed or incomplete, and repeating this inefficient process month after month made the cost, both in time and money. Let's start with an overview of the entire data pipeline architecture. The process starts in the AWS environment. It's fully automated and kicks off on the first day of each month when in the AWS in this environment, AWS event bridge triggers the workflow. From there, AWS Step Functions orchestrates a set of Lambda functions responsible for fetching, transforming, and distributing data across platforms. AWS Secrets Manager securely provides credentials when needed, such as API keys and webhook, ensuring sensitive information is stored and accessed safely. Slack notifications keep the team informed about any failures or successful completions. All this proceed data is stored in Amazon S3, which serves as the central durable storage layer. A key part of the architecture is the Google Cloud Storage Transfer Service, which automatically transfers data from Amazon S3 to Google Cloud Storage. Then the BigQuery data transfer service pulls data from Google Cloud Storage and loads it directly into the appropriate BigQuery tables, automating data ingestion without manual intervention. And finally, Looker dashboards provide visibility into the proceed metrics and different insights. Lambda functions are the main workers in the pipeline. When new data arrives, step functions coordinate how it gets processed. Instead of trying to handle everything at once, we split the data into sequential phases. Each Lambda can handle up to 6 megabytes of payload, run for a maximum of 15 minutes, and scale to around 1,000 concurrent executions. So splitting isn't just a nice to have, it's required to stay within these execution limits and keep the system stable. Next, we apply rate limiting. That ensures we respect API quotas and don't overload downstream services. This keeps the pipeline predictable and avoids throttling issues. Then, the phases are proceed sequentially, but multiply Lambda functions. Phase 1 completes before phase 2 begins, and phase 2 completes before phase 3 begins. Within each phase, Lambda functions can run in parallel, but phases themselves are sequential. This design gives us control processing flow and prevents API overload, ensuring we don't exceed our provider platform rate limits across different API endpoints. And finally, whether all phases succeed or some fail, Slack Notify sends a summary. It includes how many records were proceed, any errors that occurred, and the execution duration. But Lambda isn't doing this alone. It's all coordinated by step functions. Step functions orchestrate the entire security data flow. They control the sequence of processing phases, ensuring one finishes before the next begins. And this keeps API usage predictable and prevents SaaS endpoints from being overloaded. Within each phase, the workload is split into parallel batches, speeding up execution and keeping processing times consistent. The pipeline runs in 3 sequential phases, each fitted to the type and scale of the data. And here, phase 1 ingests threat intelligence via GraphQL API, split into 3 parallel batches to handle large volumes efficiently. Phase 2 processes user security data through REST API, managing user across 3 parallel batches, which represent the largest dataset. And phase 3 handles organization groups and phishing test results through also REST API in parallel. Since these are smaller datasets that can be proceed together without exceeding API rate limits, and the sequential execution between phases ensures control API load, avoids throttling, and prevents timeouts that could occur if all data pipeline run in parallel. If something goes wrong, step functions provide shared error handling. In this way, capturing failures from any phase and sending detailed Slack notification with phase, Lambda, and also error details. Additionally, the step functions console gives visual monitoring, making it easy to pinpoint where the failure occurred. And each Lambda function has its own retry logic for temporary errors. If a Lambda fails completely, the error is captured by the shared error handler and reported, and not endlessly retried. This gives our team clear visibility and control over when to restart the pipeline or investigate further. Since the entire system moves security data between AWS and Google Cloud, security is a fundamental part of the design. So we store all API keys and secrets in AWS Secret Manager, so no credentials are ever hard-coded in Lambda functions or configuration files. While we don't yet have automatic key rotation, centralized storage makes manual updates much easier for that case in this presentation. For cross-cloud authentication, we use Google Web Identity Federation, and this allows Google services to temporarily assume a specific IAM role in AWS. That means no long-lived access keys are stored anywhere. Google Storage Transfer Service uses these short-term credentials to securely access the S3 bucket. And this role follows the principle of least privilege. So even if something went wrong, the consequences would be small. All data is encrypted both in transit and at rest. We use HTTPS and TLS for all API calls and data transfer, and both S3 and Google Cloud Storage handle encryption at rest by default. We also have logging through CloudWatch, Amazon CloudWatch for AWS, and Google Cloud Logs for GCP. That gives us visibility into API calls and access patterns. And Lambda functions run with minimal IAM permissions, accessing only the specific secrets and S3 resources they need for processing. To make sure this security pipeline runs smoothly, we also need monitoring and alerting. We monitor everything at the batch level. Slack notifications show us exactly how many users or thread records were processed and whether there were any errors. All Lambda execution details go into CloudWatch logs, and step functions give us a visual workflow to see each phase's progress. Currently, we rely on Slack notification for error awareness and manual monitoring of CloudWatch logs for detailed troubleshooting. This allows us to track pipeline health and react to issues when they occur. Once the data is processed, it moves to Google Cloud, where BigQuery takes over. When the security data reaches S3, Google Storage Transfer Service transfers new files to Google Cloud Storage. This service uses a federated IAM role, so no permanent credentials are required. Transfers can run daily or after the monthly processing is done. In our case, this is monthly. Once the data lands in GCS, Google Cloud Storage, BigQuery Data Transfer Service loads it into tables automatically. It validates the schema, handles conversation, and deals with errors if needed. Each batch has a timestamp, so everything is organized chronologically. We partitioned the data by processing date, which improves performance and makes queries faster. Because BigQuery is serverless, we don't manage infrastructure. This means security teams no longer need to manually export files or upload them to dashboards. And the raw data is available in BigQuery just a few hours after the pipeline runs, ready for analysts to transform into the specific reports and Looker dashboards they need. So yeah, in that case, this is approximately 2 hours after the pipeline starts. So it's fast. This pipeline completely transformed the way we work with our stakeholders. In the past, security teams spent tens of hours each month on manual exports. Every report required logging into multiple systems, downloading files, cleaning data, and validating results by hand. It was repetitive, slow, and left almost no room for strategic work. Today, it's 10 to 20 times faster. A process that once took days can now to be completed in a matter of hours, fully automated from end to end. We used to spend up to thousands of dollars every year. Licenses, extra tooling, and the hidden cost of people's time added up quickly. Now the cost is about 10 times lower. By consolidating steps and removing manual overhead, we're saving not just money, but also budget capacity for what actually matters. The process was once error-prone. Manual entry, version confusion, and inconsistent formats meant mistakes were common and hard to catch. Today, we're down to near zero errors thanks to automated checks. Validation is built in at every step, and alerts flag issues before they can cause any damage. Yeah, and there were multiple human touchpoints and exposure risks. Data passed through too many hands, creating operational friction and potential security gaps. Now it runs on a zero-touch workflow. No manual transfer, no weak links, just a secure automated pipeline from source to destination. And decision making, it could take days or even weeks. Teams had to wait for reports, verify numbers, and manually consolidate findings before acting. Now we make same-day calls with confidence. With clean, verified data delivered automatically, leaders can act faster, smarter, and with greater trust in the results. But this is only the beginning of our journey. One of the biggest advantages of building this pipeline is that it gives us a solid foundation for future integrations. The first time we had to design and develop everything from scratch, infrastructure codes, batching logic, and the overall architecture. Now these components are already in place, and we know exactly how they fit together. The initial build took around 6 weeks, but each new integration based on this framework should take about half that time. For a new platform, we still need to write some code, of course, mainly to connect to the new API and map the data, but we can reuse what we've built and learned. There's no need to reinvent the architecture every time. And this approach works best for platforms without native BigQuery integrations, or when we want to process and transform data in AWS before sending it to GCP. It's also ideal when we need to unified view across multiple systems or when data is updated periodically, like in our case, monthly. It's not designed for real-time or high-frequency updates, such as hourly intervals. Shortly, we still need to implement each integration, but having this pipeline and the experience behind it makes the process faster, more consistent, and easier to deliver. Right now, we receive reports on Slack and store logs in CloudWatch, but GCP monitoring is mostly manual. We have to check storage transfer and BigQuery logs ourselves. Next, we want to implement proactive monitoring and alerting directly in GCP. This way, the system will automatically detect and fix issues where data processing happens. If a BigQuery load fails or a storage transfer job stops working, GCP will send an alert and automatically retry the job. We won't have to identify and fix these issues manually. And adding new data will also become easier as GCP will automatically update schemas and validate data before loading it into BigQuery. We will further optimize query performance and cost through intelligence slop management and materials view. This is just part of the plan, but we expect it to evolve as our approach matures. And of course, we learned a lot during this project. Breaking large SaaS API calls into smaller Lambda batches worked best, is faster and makes troubleshooting much easier. Step functions gave us reliable orchestration that's easy to maintain and audit. Storing credentials securely in AWS Secret Manager was key for both security and maintainability. Using built-in cloud tools gave us secure and stable data transfers without extra overhead. and good monitoring. In our case, through Slack notification and CloudWatch logs helped us detect and fix issues early. That's how we built and automated our SaaS data pipeline for now. If you have similar experience, of course, or knowledge in this area and would like to share insights with me, I'd be happy to listen and learn from your approach. Yeah, thank you for listening. I'm happy to take your questions. Also, if you have no question now, feel free to connect with me on LinkedIn and ask me any questions later. Yeah, so always I try to respond as soon as possible in my private messages. So yeah, thank you so much. And of course, I invite you to take part in the quiz. You can win cool prizes. And yeah, so enjoy tonight the pizza and drinks, of course, etc. So thank you again, and yeah.
Hello, Julian. Do you hear us?
Yeah, I hear you.
There isn't any questions from the crowd here?
We got one.
You have a question?
Yeah.
Very good. Very good. Please.
Hey, hello.
Louder.
Louder. Okay, hello. Just wondering, is there any reason for going both AWS and GCP route? Like, was there any specific feature inside, I don't know, big table, right, or something like that that caused you to try to go between two clouds, or some missing features in AWS, or was it a cost perspective? Basically, yeah, not challenging, but asking like, why complicate things if potentially you could do this thing in one specific cloud?
Yeah, to be honest, I think maybe it could be some solution for your question, but for that specific case, we need to respect some requirements of our stakeholders. So that's why we use the GCP and AWS together, because some platforms, I can say maybe the exact name of the exact platform from which we needed to transfer the data to BigQuery. But finally, all data we show to our stakeholders from Looker, which is a GCP tool. So yeah, so that's why this specific case is so specific. But you gave me some insight, I guess, and I need to maybe find some really good answer for your question. Because I think maybe we have something which could be good, yeah, to answer for a question.
Do we have another question, maybe?
Sorry, can you repeat, because I couldn't. Yeah, I can't hear you. Oh, maybe now. Okay, now I can hear you, but I'm not sure if you said something else. Okay.
So, do we have any other question? I don't think so. So let's thank you very much for your presentation. Let's give a round of applause, please. So we will be having around 10 to 15 minutes of technical break to prepare for the next speaker. And also in the meantime, as always, we've got a quiz, which will have a lot of nice rewards at the end. So let's try your chances and really going for a break. Thank you.
Nie musiałem tego dołożyć.
in 1 minute.
Okay.
Okay, so let's start with our second part of today's meeting. Right now we'll have Rafał talking about backups. So as probably everybody knows, all of us should do backups or will be doing backups. So let's go with a round of applause for Rafał, and I'm giving him a mic.
Okay. Hello guys, I'm Rafał from evoila. Today I show a short presentation about backup with a Commvault with S3 from Amazon. Okay, let's start. Short agenda. Introduction. What is Commvault? Second. Backup and environment architecture, simply for architecture. Next, configuring backup in Commvault to S3. Short study how make it simply. Next, backup options from Commvault. It's three nice backup options: data recovery and benefits and summary from backups. Okay, that's introduction. Commvault is simply an easy environment for backups. We can make one conserve, install it, and go to web service, and it's all. Next time we must configure plans, data storage, and AWS S3. We can back up file servers, VMs, laptops, users. Active Directory is a good feature because we can back up all domain from Windows Server, and it's work smart and fast for me. We can have multiple storage, SES, data domain, and S3. Now I test S3 a lot of times, and it's work good and fast. We can back up virtual machines really fast. 1 terabyte per hour is good result for network backup from Frankfurt server. Okay. Now we talk about backup architecture. The simplest architecture is Media Agent to S3 Cloud. We just make one virtual machine with Commvault. It's Windows or Linux. At the latest version of Commvault, we have just Linux for Commvault and web server. I prefer Windows on the free last version, and it's my best option. we just make media agent and choose backup targets, VMs, file storage, Active Directories, vCenters, or other things. We can back up all VCF solution. And it's simple. We just make privileges for user, connect by IP, and it's done. We just choose plan, which Commvault can back up this VM.
Możesz, chyba nie, teraz nie będzie, na pewno nie będzie. No to ściszone do zera. Dobra, no to jak dasz radę bez mikrofonu, to będzie...
To musisz głośniej mówić.
Musisz głośniej mówić.
Okay, let's resume.
Sorry guys, sorry, technical break.
First architecture is most simple, but second architecture is high availability media agents with load balancing. We make one concept, Windows or Linux, for media address, Windows or Linux. We can choose. Next, by load balancing, is going to local staging or modification, and next by object API going to S3 bucket. It's the second architecture. Next, we can make direct cache to S3. We may conserve three media agents, local, posterior mask, or object gateway, on-prem, VMware or other things. And next, we go to S3 bucket. But I prefer multi-target, multi-vendor, S3, SCS, plus on-prem. Concept, three media agents or more. We can make a lot of media agents. Local identification and load balancing, and going S3 bucket primary, SCS for replication, S3 comeback for archive. It's cheap, and we can archive data on S3. I think the last architecture is the best for projects, for the ends. I use last architecture and it's the best, it's fast, simply, and we can really easy make this environment for Commvault. Just install it without much. And click next when you want to install Commvault. Just make a network and okay, now we go to configuring backup in Commvault USB. Really easy, fast. After we install the Commvault, go to click the link, login by admin and password. We go to really easy and quick setup. Just add storage, LAN, and that's all. And something to backup. Okay, but first, if we want to go to S3 bucket, we must make a bucket. Just name a bucket test123 or something. ACL as the same. This is recommended for Commvault too. We block all of the access. Bucket versioning is difficult for default. And that's all. We make bucket, S3 bucket, to make bucket. But user by IAM is the most mess. We must make user next. Take the largest thing and copy the second square peg. It's really important to connect S3 Commvault. I make access policy. Commvault then S3 access. We just want these things. You can make by admin, but it's not secure. It's permissions for working the S3 group. Shall and arrows and other things to make backups better or don't restore something from S3. Next, it's all. That's all. Review is not tax, it's optional for us. Just create user, and next we must make an access key. We can choose third-party service or application running outside AWS. I use third-party service, but it's preferred to use application running outside AWS because it's safer and Commvault prefer this. Working is properly, but other options is not accessible by phones. Next, we make access key, just copy access key and secret access key. And in next step, we pass them to the Commvault storage. Yes. We just make the credentials, cloud account, Amazon Web Service, access and secret page, credentials for building. Credential name is as we demo, we can type everything what you need. Just pass access key and secure access key. Click save and that's all. That's new. If we want to add storage in S3, just make name, choose the media agent, storage class, radio, service host authentication by IAM, and choose credentials. And last important thing is name of bucket. You must type your bucket name. So just click next, and we can make or choose plan backup. You can make a lot of things of backup plans. I think the default Commvault plan, backup plan is good, but we can modify to our preferences. Next, we choose the retention to save storage in S3. I choose 1 month or 14 days to save all files on S3. Click save, and that's all. It's really very simple. Last, we continue RDO to making backups. I think every day backup is the best. At the evening or in the night, and make backups always. That's really important for me, for us, in making backups. And next, we got configure cloud, Amazon for S3 and Amazon. Now we can choose Active Directory, VMs, VMware, or other Windows, laptops, file service, everything to backup, and we can choose the Amazon plan with S3 and that's all. And backup is making every day. Or how we choose this. Okay. Now we backup options for S3 in Gronek. This secure vault is 2 variants, standard or RD. Standard is sending data every backup. It's implemented, it's have a lot of verification, it's have 80% of saved data. And we can archive. Archive is for 1-2 months saved data. Backtrack, it's really quick to install from previous version. It's really fast and good thing to restore everything really fast. Kubernetes also. VMs, we can backup Windows desktop or Linux desktop, and it will find user who using this virtual machine don't just click F5 and says relate files is on the screen. We can make continuous backup. It's automatic data synchronization by every minute. That's really for critical systems. It's really good for critical systems. How is data recovery? Commvault have free restore. It's full. Full is backup all data. VM or from VM or from data store, everything. Incremental, it's compared to data was used and just backup. These things is not accessed on the VM. And synthetic backup is directly backup all data from S3 or other storage. It's really quick. We just click restore and restore is done. We got a job number, that's all. And we just wait for the retreat. Now, benefit and some more. Benefits of Commvault with S3 is simplicity of configuration. Configuration is really easy. We have a really good documentation on Commvault website. It's easy, quick, and fast. Security of this backup is good because we can make multiple packets and the duplication data across this S3 bucket. AWS is scalability and S3 is scalability too. We don't want to apologize about this space. S3 is flexible, but that's no problem. This problem is dollars on Amazon account. Cost of optimization. We can use different storage classes, global disks, SES or Amazon S3, and that's all. Commvault have two different licenses, by VM and by TIPS. I prefer by TIPS because we have calculating when and how many these TIPS we want to have backup across all environments of VMware. I think that's all we show. It's comfortable and that's free.
Sorry, questions? Go for it.
How Commvault handles the storage classes in S3? Is it an instance needed on AWS side, or is it on the automatically on AWS side, the transition between the, let's say, S3 standard?
By default is position, but we can choose this. In Commvault web service, we can choose this for our preferences.
Do you know if there's an instance on AWS side needed? Is it to be instance to the transition?
I don't know.
Any other questions?
I have questions regarding connections. You use a user, but I'm wondering if you by any chance investigated if it's possible to use this tool by using role instead of user to avoid the problem of persistent credentials.
We don't have a lot of credentials which Commvault needs. You can access the S3. It's you just show error and that's all. I like
That's not what I mean. I mean the problem is that user technically is long-term credentials. Roles is a temporary credentials. That role is assumed, for instance, from other account, and this way.
yes, it's working. To time if your credentials is right. And we got email and about error of hardware.
I also have one question. What's the main advantage of using this tool and not other, for instance, AWS native tools, EBS snapshots, etc.?
This solution is for ongoing. It's really flexible, but I think best AWS snapshots for others. I can compare it. I think in another book, but for me, Commvault is really good backup environment for this time. It's really flexible and really light for our environment for
Questions?
No question. Okay.
You mentioned 2 licenses. What's the average cost for like a small department?
Commvault have a calculator like AWS, and we can calculate how many dollars we need to spend to buy a license. And a lot of things is by Commvault have a lot of licenses. We can choose what we want to buy. But my tip is the best licenses, not for games.
So, do we have any other questions? Good, thank you.
Thank you very much. No need for mics. Did you make the quiz? It's done? All happy? Good. First, people who ask questions. This is from our partner for today. This is from all right. Very good. Good. Come on. We have something for you. Looking very kind of questions. Very good. Oh, you get along. Perfect. That works. Hey, you wanted to check, right? Yeah. Old one. Great. James. Oh, yeah. All right. Good. And now quiz, right? We have results.
Yes. So the first, and please remember about vouchers.
Yes.
Okay. First winner is Camila.
Camila. Where's Camila?
Camila 97A.
Camila 97A. Online.
Maybe she's online.
Yeah.
Okay.
Voucher.
Voucher. One moment. I need to.
Write down because we forget it.
Exactly. So next one, Semehen.
I always say. All right, Maria.
Lech.
Lech. Come on in. Everybody get pizza.
The last one, yeah?
Yep, and last one, right? Yeah.
Paweł Masłowski.
Masłowski. Come on, it's everybody.
I received one, but
I have no idea what to do.
You can swipe with someone.
Universal.
Okay. What does the rest of my
The rest of options, right? Okay. So how many we have?
4, because one of is. Yeah. So maybe this one from the end.
Yeah.
Daniel Sopel.
Daniel, okay, you will get a voucher. So don't stand up. I don't have to print it. I'm not that old. I'm not that old to print AWS vouchers.
Okay.
Sure.
So the next one, yeah. Ameotoko. Ameotoko. 1.
All right.
Okay.
The vouchers, you will need that. No laboratories in AWS Commvault.
Mati 852. Okay. Tomasz.com. Okay. Nice to meet you all. And the last one, yeah? Anna Wojakiewicz. Ania? Ania Wojakiewicz? Okay.
Hey, you get a car.
Okay.
Perfect. Thank you very much for coming here. I know that today it was 3 other meetups happening, right? And this was your choice. 3? I don't know, 3,
one for sure.
But thank you very much for coming, and we will meet pretty soon again. 76th meetup. When we have it?
When? I think in January.
Yeah. So before Christmas, Merry Christmas for everybody, and Happy New Year.
We are first.
Yeah, thank you very much. Stay for now.